Now that our artwork is created for our sprites, it's time to start adding them to code. If I look inside my data folder, I can see my artwork exported beautifully, and there it exists. And I have created graphics, PNG graphics, that are 64 by 64 pixels in size. Both my cow and Clover are the same size. It's important to keep track of the size of your artwork. You do not have to make it square. It's just convenient right now for what I am doing on these demos. Inside my project, with the sprite start file, the first thing I need to do is to modify the height and width to match the size of my artwork, which is going to be 64 and 64. Now, everything else will be good to go, and we'll talk through a little bit more of what all of this is in just a little bit once we have the rest of the code worked out. Previously, with our artwork, all we had to do was say image, the name of the image we're looking at, and where we want to put it on screen. Well, now we're going to have an array of images, so we have to figure out what to do with those. There's a few extra variables here that are left in because we will be adding them in as we evolve our code later on this session. So I have my sprite S. I have a sprite images array that's filled with pictures. Remember that we always want to load our images in the beginning and not inside of our individual classes, but we want to take care of all of our loading of assets in one place. Then I need to store a number that is my sprite frames. That's how many frames or how many images are going into that array. Now, the number of images that I'm going to load for my sprite animation is not 23, but for the Clover is 19. So I'm going to change that number to 19. So I have set it up, 19 frames. I'm going to call load assets. Load assets, down at the bottom, sets sprite images equal to a new pimage array, and the length of that array is the number of frames that I'm going to be having in my sprite array. Then I have a for loop that cycles through and it populates that array. So this is very similar to where we had our array of drops in the catcher game, but now I am loading images into an array. The next thing we need to look at is our sprite images line where it says load image. What we are doing is we are loading an image. In this case, the name of my image will be Clover. And what I really want to do is I want to load Clover 0001.png, Clover 002.png. If we notice, this is a numbered sequence. When I use my for loop, it's going to be a numbered sequence where I represents a number. In this case, I starts out at 0 and goes up to 19. But as we look at this, what we want to do is we want to load all 19 images. And processing has a cool feature where it's called number format, NF. And we say, I want a number, in this case I plus 1, to be represented as 4 numbers. We look at our name here, 1, 2, 3, 4 numbers. So it's a really slick way that we can work with to say, now if we only had 9 images, what I could do is instead of using number format is I could say Clover 000 and then the numbers 1 through 9, and that'd be great, except that I have 19 images. So that doesn't work. So we need to somehow get these extra zeros on, but we only need 3 zeros or 2 zeros. And if my animation was 100 frames long, then I would need 1 zero or 2 zeros or 3 zeros. So instead of trying to write an if statement and deal with all of that, we can just reformat our number to display as 0001, 0002, up to 0019. So number format says I want 4 characters of number. The number I want it to start with is I plus 1. That corresponds to my numbering that animate gave me. And then we finish with a PNG. So it will spit that part out. So it's a really convenient way of making that happen. Now I'm going to tell processing to print this out just so we can see this statement happen when it loads the images. If I run my file and say there's my Clover and it's animating, and if I look down here at the bottom, and stop that so it doesn't keep running. So we got Clover 1, 2, 3, all the way up to Clover 19.png. So to recap, we have an array, in this case called sprite images, that we are loading with all of our Clover image files. We're loading, the number of frames we're loading is sprite frames, which corresponds to how many files there are. In this case, it is 19. Our draw, it's just like before, sprite update, sprite display. If we look in the sprite, it has a update and it has a display. Currently, it's not doing anything to change its position and update, so that's why it stays parked there. The image command then tells us to look at whatever the current image is inside that array. Now that current frame we're looking at starts out at 0. The first item in our array is at position 0. So I say show me in sprite images the object at position 0. Then we make current frame go up by 1. And if current frame is equal to the total number of frames inside our animation, it resets current frame back to 0. This is how we create a permanent looping animation. So we say count up to, in this case, 19. Once we're up to 19, go back to the beginning. And if I look at my animation one more time, we will see that's exactly what happened. Is it now creates this permanent looping animation. So my sprite knew when it was created that it needed to have 19 frames. Because when I said s is equal to a new sprite, I passed in that number. Now that the sprite is animating, it's time to make it respond to input from the keyboard. Now, if we want something to respond to input from the keyboard, we can reference things in our draw function. There's a bunch of different places that we can do it, but at the end of the day, what's nice is processing has 2 built-in functions, one called key pressed and one called key released. And within those functions, what we are going to do is we are going to be listening for when a specific key on the keyboard has been pressed and when those same keys have been released. What's nice is every key on the keyboard has a numerical value associated with it. So we can now listen for that information. For the characters are contained in ASCII codes. So if we look at an ASCII, American Standard Code for Information Interchange, ASCII, we see there are numbers, and these numbers correspond to pressing specific keys on our keyboards. So we have HTML character codes. We also then will have specific codes that will respond to the different letters. We will see that they respond to the space bar, return key, the arrow keys, and the keys that we will be using are going to be our arrow keys, which correspond to 37, 38, 39, and 40. So we will be listening for the arrow keys. Now, there are 4 Booleans, and what we are going to do is we are going to set these values equal to true or false depending on when a key is pressed. So when the left key is pressed, we want our Boolean left to be equal to true. When you release the left arrow key, we want the Boolean for left to become false. And this is a way that we can then better work with this, because we could set up inside when we press a key that if that key has been pressed, then we have to wait for the key repeat rate before our object starts moving, and then that causes no end of headache. So if we just say when a key is pressed, we'll just give it a speedx equal to 5. So when I press a key, in this case it's going to be any key, now it keeps moving. Now if I release the key, it stops. But this movement is corresponding to the key repeat rate of I've pressed this key and it fires off, and then it will fire off again based on whatever my key repeat rate setting is in my system preferences. So currently my key repeat rate is set to fast. So if I set it to slow, there's more of a lag happening at that point. So it's not going to be as effective of a way to control the playback of the animation. We don't want to directly reference that there. We will instead want, when a key is pressed, in plain language, we want to say if the key is the left key, then set left equal to true. So that's what we want to do. And we can use an if statement to do this, where we can say if the key that's been pressed is the left arrow key, then left is true. And then under key released, we can say if the key that was released is the left arrow key, then left is equal to false. But there's a more concise way of writing this, and it's called a switch statement. But I'm first going to write it out using a series of if statements, and then we will convert it into a switch statement so you can see the difference. They both will work. So it's not that one versus the other is mandatory, but they are worth considering. So if I say if the key code is equal to 37, left is equal to true. Else, if key code is equal to 38, up is equal to true. Now, if you look at your arrow keys, we're starting with the left arrow, And we move in a clockwise manner. Up is next, then we'll have right, and then we finish with the down arrow key. So that is the logic for left, up, right, and down. Else, if key code is equal to 39, right is equal to true. Else, if key code is equal to 40, down is equal to true. We do not have a final else, but if it makes you feel complete and you want a final else, we can put it in. It was some other key. So we can just put a comment, because we're not going to do anything if it's some other key. So when we look here, we'll see we've now set these options. If I run my code, oh, ended up with an extra equal sign there. Run my code now, I can press any key on my keyboard and nothing happens, because while I'm setting these equal to true, I'm not doing anything with it yet. And that's where inside our sprite, we're going to let the sprite worry about, hey, when this is true, then the sprite knows, hey, good, if left is happening, I'm going to start moving around on screen. So inside our sprite, if left is true. Now I don't have to say if left is equal to true. If I just say if left, that is the same thing, because I say if left, and left can have a true or false statement, and if or a conditional is always wanting a true or false statement inside my parentheses. So if left, speed x is equal to -5. If right, speed x is equal to 5. Remembering that -5 will make it go left, +5 will bring my sprite to the right. If I run my project, if I hit right, well, I hit right and shoot, it's gone. Let's try again. Hit left, oh, it's gone. Oh. And now I can't get it back. So what we see is that right outweighs left. And that makes sense because of the order or the sequence in which these happen. But also it makes sense because we're not doing anything with released. Once I press a key, it takes off like a bat out of hell and doesn't come back. So we need to work on bringing it back. And that part of that is to have a key released where we can set the values equal to false. Because at the moment, I can only press a key, but if I release a key, the program has no idea that that event occurred. So this is what it looks like using conditional. Now I'm going to write the released using a switch statement to show how to do that differently. And if I do it, I use the word switch. Now I'm going to reference my key code again. Key code is the numerical value that is associated with whatever key has been pressed. And the syntax for a switch is I'm stating cases. And I say, for the case of 37, now I'll give myself a comment here and just say that's left. Then we can say left is equal to true, false now, because this is my key released. And if that is the case, then we need to put a statement in where we say break. And what that means is it says, hey, this one is now the correct one, so don't even bother looking at the others. Break says, get out of here and stop looking. And right now you may be saying, but what others? Well, I haven't put the others in yet. But if I say case 38, that is going to be up. Up is equal to false. Break. Now you'll see that there's a lot of redundancy going on here, so I'm going to speed it up using copy pasting. So now I'll have a 39, 40, right, right, down, and down. When dealing with key codes and cycling through key codes, more often than not, you will encounter switch statements because they keep the code a little bit more organized compared to the conditional with all of the extra curly braces. If you want to use a conditional, an if statement instead of a switch statement, that is completely fine. It's up to you on what to do with that. If I run my program, now I can let go of the keys, and now I can actually go back and forth because I'm dealing with the release values. But I still can't stop moving yet because my sprite hasn't figured out how to deal with stopping moving. Because right now I have if left and if right, but I haven't taken into account if not left and not right, meaning if left is false and if right is false. At that point, what we want to do is say speed x is equal to 0. So if I'm not pressing either key, it now stops. So I don't have to press a key to make it go. Some people will enjoy a nicety where we can say if not left and not right, speed x is equal to 0. We can also have a second statement or compound it where we say if left and right. And that means if I'm pressing one key and press the other one, so I can't, if I'm pressing left and right, it doesn't go anywhere. So if I'm pressing one and hit the other one, it stops it. That's an optional, and you can decide if you want that as part of yours. To recap, I have a key pressed using a conditional with lots of curly braces. I have a key released, which uses a switch statement, much cleaner. And then my sprite listens for those values and says, hey, if left, then we need this speed x. If right, we need this other speed x. But if I'm pressing both or not pressing either, my speed x should be 0. The next challenge is to then control speed y so our sprite can move left and right and up and down. Those additional changes need to take place inside the sprite update method. adding an enemy class, I click on my plus here and I will say new tab. This new tab, I am going to title this enemy. So now I have my enemy class. I'll go back to my sprite class, and the first thing I can do is just copy everything, go over to enemy and paste, because both will be very similar. Their displays will be near identical. The updates are going to have similarities, but not based on left, right, up, and down. And the rest of the constructor parts will be similar, but I do need to remember to change my class name to enemy and my constructor name to enemy. After that, the size is still the same. I created both at 64. I will position my enemy at a random number, and I will say random 200, 500 on the width, and a random 100, 300 for height. So my enemy will be at some random position. X and Y correspond to my cow file artwork. The update will need to be changed. If I leave that for now, we will see some interesting stuff. So I'm going to leave it just so that when we add the enemy, it will move based on me moving my artwork. Now, the next thing that I want to do with my project is to add my enemy in. Currently I have a sprite, and I have sprite images and sprite frames. So I will need 3 more variables, and this will be enemy. I'll call it E. And then I will create my array of images. And this would be enemy images. And then an integer for my enemy frames. So I could have copy pasted and just changed the particulars, but it's easier to, in this case, just type it out. Now, what I want to do is to define similar things in similar places. So enemy frames, in this case, is 18, because I have 18 images for my cow. And then I can say E is equal to a new enemy, and I will tell it how many frames it has. So we pass in that number. So we're getting very close to being able to see our enemy show up on screen. It's not going to chase our player or hero yet, but at least we should be able to see something show up on screen soon. If I say e.update, e.display. If I run my project, well, notice that I have 2 versions of my dancing clover. Now, I told it to load my enemy artwork, the cow, but I forgot one little thing. Inside the enemy class, in my display, it says use an image in my sprite images. But we don't want sprite images here. We want to use our enemy images. So we pass in the correct array. And now when I run it, but I forgot inside my load assets, I never actually populated my enemy images array. So I created the array. I now know how many frames, but then when I tried to use it, I forgot or neglected under load assets to ever load my enemy images. So I have to change my occurrences here. from sprite to enemy. And this time load my cow instead of clover. So not only did I, in my enemy class, reference the wrong array, once I changed it to the correct array of pictures, I forgot to ever load the pictures into that array, which of course then that's why I have a null pointer error exception. Null pointer means you are asking for something that does not exist. The word null means not existing or nothing. And in this case, when we see null pointer exception, that is a reference to the fact that you asked the program to find something that is not there. And now I can see I have my cow and my clover.
What do you do with 6?
What we need to do to allow our enemy to chase after the sprite is we need to tell the enemy where the sprite is. Inside my main document under e.update, I am going to pass in the x and y location of my sprite to the enemy. This way the enemy will know about the sprite.
There's an error message right away.
Message right now says the function update does not expect any parameters because the enemy's update function, if I look at it, it's not looking for anything. And all of this good code that I have here, except for the update, goes away. Or the plus equals speed x plus equals speed y. So my update wasn't expecting anything, but now I'm going to give it an x, a sprite x value, and I will give it the sprite's y value. Now I'm just using sx, not s.x, because technically, when we are doing objects and working with classes, one object can't directly access or should not be able to directly access the variables inside another object. We can pass that information to it, but it shouldn't be able to automatically just know. The enemy can't go, oh, I look over and see where's the x. Our main program is our controller, and it needs to then share that information with the parties that need to know. So classes, by convention, should not be able to access data inside another class. Now I have a warning, it's not red, it's orange. It says the value of parameter sx is not used. It's like, well, yeah, I haven't had time to use it yet. First I have to figure things out. What I want to do now is to start out and say if, not if the distance of my enemy x comma y and the position sx comma sy of the sprite. So if that distance is less than 200 pixels, at that point, do something. Start the chase. Now I need to figure out how to actually do that chase. What I want to do is close the gap on the distance that is larger. Are they further apart on the x-axis or on the y-axis? And I can determine that through the magic of the ABS function or method, which says give me that absolute value, I don't care if there's a plus or a minus in front of it, of x minus sx. So that says the x position of the enemy minus the x position of the sprite. I subtract those two numbers. And it tells me what is the actual distance between them. and throws away any negative sign if there is one. Because if the enemy is on the right side of the screen, the player's on the left side, when I do the math, I will end up with a negative number. Even if they're 400 pixels apart, it would be negative 400. And negative 400 is probably going to be bigger than the other dimension because my whole project is only 600 pixels tall, or 400 pixels tall. So I don't really, that wouldn't work very well. But if I say throw away the negative sign, because they're 400 pixels apart, I don't care whether it's a positive or negative distance between them. I just care how many actual pixels apart. So then I will do my next ABS for my y minus sy. And that if the x distance is less than the y distance, that means I have a bigger gap on the y-axis. So I can say if y is less than sy, meaning the enemy is to the left of the sprite, or sorry, if the enemy is above the sprite, then we will say speed x is equal to 0 and speed y is going to be equal to 2. Because if the y of the enemy is less than the y of the sprite, we want it to go down. Moving down means I have a positive 2 value. But and my only two options are either I'm above the sprite or I am below it, so I can just use a simple else. Enemy is below the sprite. Should put a comment in here. When doing these different calculations like this, it's really useful to have the comment so you can keep track of what your if statements and what values you're thinking of. Is above the sprite. Now speed x is equal to 0 again, and speed y is equal to negative 2, meaning I want it to go up. So if the gap is bigger on the y-axis, then we close the gap on the y-axis. Otherwise, gap is bigger on x-axis. And get my closing curly in before I forget it. And now that we have that, if x is less than sx, speed x is going to be, so if my x is of the enemy is less than the sprite's x, that means I'm to the left, so I need to have a positive speed value. So I should put in a comment, enemy is left of player. And once again, speed y is equal to 0. Close that out. Else enemy is right of player, or sprite, player, sprite, and I'll be consistent on my naming. But it really is, if one item is being controlled by the keyboard, it really is like being the player in the game, so we can refer to it as player and enemy. Speed x is equal to negative 2. And speed y will once again be equal to 0. So making sure I've balanced out my ifs. That if goes to there, that one closes to there. This if needs to close, and it looks like I'm missing a curly brace right there. So now this curly closes with that else. And now this curly, where's my gap here? So if this is there, now the distance, so I'm still missing one more curly. This distance, that one needs to close with my distance. A good technique when we have so many nested curly braces is to put in comments on the closing curly to correspond to what it needs to close on. So this I can say end X move here, and this closing which ends with the distance, but I really don't want to end the distance just yet, because if I'm not going to be moving on any of these axes, then what I want to do is to kill my speed. And that will stop the object. We can do that. It can sometimes be fun is to then just put wiggle code in, so then it causes the object to jitter around just a little bit of random movement instead of just making it stop dead. So then it just starts to wander and move around on screen on its own if it's not actively chasing the player. And when I run the project, we'll see that it starts moving after the player when it's within 200 pixels. When you set something up like this, it's a good idea to make sure that you give the player the ability to move faster than the enemy. Otherwise, you will have issues that you can't get away. That may be part of your game plan, but you will want to work through that.